as usual. We're just chatting. I would say this is more like a little, at least my intention is to just make a little review or study along with me, I guess. Someone had commented that they are learning about polynomials currently, and I thought that we would bring the study party over to them. So we're going to bring in polynomials into our little math nook, and you can feel free to just zone in and out as you please. So I know that math is not always a relaxing experience for people. I definitely acknowledge that. So just wanted to encourage you to, just for this moment, to just let any concept go of whether or not you think you're a math person, or if you think that you're good at it, bad at it, or any of that, because right here and right now, you have chosen to show up as you are, and for that I am very grateful, and that is what we are celebrating first and foremost. That's what the whispers are about, that's what the relaxation's all about, that's what the ASMR is all about for me, for here. So, I hope that you feel safe, comfortable, relaxed. Maybe catch a tingle or two. Maybe you want to just drift off to sleep, which is totally okay. I won't get mad or anything. Or maybe you'll want to play around with some of this math with me. Okay, so what is a polynomial? Well, the root breakdown is poly means many and nomial means names. So many names. But I don't think that that's terribly helpful at all, because what are the names? What does that mean? And honestly, you have a lot of names, right? You're cutie patootie, you're math angel, and presumably you have an actual name. So you have many names, but are you a polynomial? I don't think so. So, although now that I'm thinking about it, that could be a cute role play, an ASMR role play. What do you think? Probably not. Okay, but no, that's not what we're talking about here. Names, we actually mean terms. So we're going to break down what a term is, and more specifically, there are certain rules for the terms for polynomials. And not only that, the many part is a little bit, we're going to have to put some quotes for that. Many terms, because there is such thing as a polynomial with one term. That would be called a monomial. It's a subclass of polynomials, but some polynomials only have one term or two terms, which we've actually talked about binomials here. We talked about factoring binomials. So by many names we mean many terms. Alright, so let's chat about what a term actually is. I'm going to do my best, but in general, it is your basic building block for an expression, and the blocks are separated is what I meant, separated by a plus or a minus sign. So we have a block, and then maybe plus another block, and maybe minus another block, and we can have as many of these as we like. And in fact, we can actually just have one with no pluses or minus or anything else. But if we have a plus or a minus, then we move on to another term. Alright, I'm not going to try to repeat that because I probably wouldn't be able to say it again. But stuff that is separated by pluses or minuses. How's that? So, what does that mean? This is a basic basic building block. So that means that if we had another plus or a minus anywhere within one of these blocks, that block would separate into two other terms, right? So we're talking about the smallest unit that doesn't have any more pluses or minuses. Otherwise, they would split up into two other terms. So then what is allowed within these? So these things can include multiplication, exponents, division, numbers in front, all kinds of stuff. But when it comes to polynomials specifically, there are specific rules for the exponents parts. So I'll write that out. But let's say we start with the variable. Let's just say x, the most generic one in algebra. So x alone, actually without anything else, is technically a polynomial. You could think of it that way. Usually when we learn about these, we start with like a constant function and then a linear function, so that would have an x, and then quadratic functions, which would have an x squared and stuff in it. So usually when we study about polynomials, like as a class, we often look at x cubed or higher, but just by definition, you could even just have a constant like 5 and consider that a polynomial. It's kind of weird, but you could. But let's say we have x as a term, and then we have y and z. So you have x plus y minus z. That can be considered a polynomial. Now the reason I mentioned the like power of 3 or higher and stuff like that is you kind of have to adapt everything that we talk about to whatever it is that you learn, because different teachers and different textbooks are particular about things, and now I've learned just meeting people from different countries that it's explained all different kinds of ways. So of course adapt everything that I'm saying to what applies for you, but this is just kind of the most general concept here, okay? So if we have x and y and z, these are variables that are separated by a plus or a minus. So we have 3 terms here, and we can add or subtract something else. So that's allowed for our term here for a polynomial. We can also put numbers in front. So let's say we have 6x plus 8y minus 3z. So when we put a number in front, that's called a coefficient. And when we squish them together in algebra, it means multiplication. So if we have x is like the number of apples, then 6x is 6 apples, or 6 times the number of apples. I don't know, that's a bad example, but 6x means 6 times x, 8 times y, 3 times z. And because those are multiplication, these are still terms. So 6x is a term, 8y is a term, and 3z is a term, and they are separated by pluses or minuses. So that's still okay. Now is where things get a little bit more particular when it comes to polynomials. So we can raise these variables to a particular power if we want to, an exponent, but there are rules for polynomials in particular that need to be followed. So exponents for the variables in particular, so that's important, we'll come back to it. The variables x, y, and z, the exponents must follow these rules. It must be greater than or equal to 0. So greater than or equal, that's what this sign is, greater than or equal to, this is our inequality stuff. So that means 0 itself, 1, 2, 3, dot, dot, dot. And technically I'm combining this, so anything that's greater than or equal to 0, it could be like 0.002 or the square root of decimals or anything like that. So that's why it's 0, 1, 2, 3. So you're not going to have an exponent of, 0.82 or an exponent of 1/2. So we're going to let these sink in a little bit and kind of look at examples that are allowed and examples that are not allowed. So basically, if the exponents for the variables must be greater than or equal to 0, so that means that it's positive or 0, so basically not negative. So we cannot have x to the negative 2 or something like that. And you can recall that if we have a negative exponent, if you've learned about negative exponents before, that just puts the x in the denominator. It's a reciprocal. So we don't want our variables down in a denominator. So we don't want negative exponents, and we also don't want like fractional exponents. So we don't want like x to the 1/2, because that is the square root of x, or x to the 1/3, which would be the cube root of x. We don't want any of that stuff. But aside from that, you can have any, positive exponent here, or 0, but we'll talk about that in a second. So we could have 6x cubed plus 8y to the 7th minus 3z, and just leave it like that. We can also, multiply other variables. So we could do like minus 3za or something like that. So we can squish together more variables if we want to. So polynomials can actually have many variables, but usually when we first learn about them, especially in algebra, we often start with just one, although it really depends in what context. But this is where we would have the y, which is a function of x thing, and you might see something like x to the 7 minus 3, x to the 4th, plus x squared minus 2x plus 9, something like that. So we have a bunch of these terms that are separated by minus, plus, minus, plus. So we have 1, 2, 3, 4, 5 terms here. And you can see whenever we have our one variable, in this case x, and we're writing y in terms of x, so this would be a polynomial with one variable. Whenever we do have an x, we are raising it to a power that is greater than or equal to 0. So we have a 7, a 4, a 2, and this is technically a secret x to the 1, but we don't write it. And so on that note, this 0 and 1 part is kind of like a special case. It's kind of optional, but there are situations where it is helpful to think of the exponents as being 0 and 1, but basically these are special cases, so you don't always see x to the 0 or x to the 1 written out, because x to the 1 is x, and x to the 0 is 1. So in this case, when we have a 9, that's actually our constant, because you could think of it as 9 times 1 or 9 times x to the 0. So you don't usually really see x to the 0. It's kind of a special case thing. So unless you had a reason, and there are times to do it, but unless you had a reason to directly write out x to the 0, you usually won't see that. And same for x to the 1, you usually just see x for the linear term. So this would be where the quadratic begins. The x squared is the quadratic term, x cubed is the cubic term. And you can even see in this particular example that there are terms that are missing, right? There's no x to the 5th term, no x to the 6th term, x to the 5th term. There's no x cubed. So that kind of brings us to a general form for polynomials. So this is an example of a polynomial, as is this, right? But we said we're going to start focusing on one variable for now, or just two variables, but one written in terms of a single other variable. But usually when we write out polynomials, if we try to generalize this, we basically have some kind of coefficient times our variable coefficient in some way, which I'm going to call a sub n. Okay, so a1 would be a coefficient of a term, a0 would be a coefficient of a term, a2. So these are just all different numbers. So a general term would be an times your variable. So for now x, but you can replace that with whatever. And x to the power of n. Okay, so that n being 7, 6, 5, 4, 3, 2, 1 or whatever. And so this is a sigma notation. Don't let this confuse you if you've never seen it before. And also, please don't let this confuse you if you're seeing like the indices be slightly different. But basically, all this means is that I am adding a bunch of terms. So this sigma thing is a summation, and it just means that I'm going to take each index here, so 0 and then 1 and then 2 and then 3 all the way to whatever this constant n is, and this n is going to be the highest degree of my polynomial, so in this case 7. So I'm adding n equals 0, then 1, then 2, then 3. So basically if I expand this out, I'd have a0 x to the 0, which is my constant term, plus a1 x to the 1. So I'm just placing numbers from 0, 1, 2, and then depending on what n is. So we're just going to write a few terms of this, plus dot 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 to a n x to the n. So what is all of this? It's basically just a standard form for a polynomial. Sometimes you'll see all of these little coefficients written in a different order, so you might see like an n and then n minus 1 and n minus 2 and all of that stuff. But basically this is a coefficient, so that's a placeholder for a number. a1 is a placeholder for a number, a2 is a placeholder for a number. So these are all the coefficients here. So an, that number, is the number that corresponds to the coefficient before x to the power of n. So in this case, n is my largest thing, which is called the degree, and the number in front of this x to the 7 is 1. It's a secret coefficient of 1. So 1 times x to the n, so x to the 7. And so what you do for this basically is you decrease the power by 1 every single time. So this is just a standard general form for any polynomial, and all this is basically taking your 1 times x to the 7, and then you move down to x to the 6th, and there is no x to the 6th. So you can just write 0. So usually you write from largest power to smallest, but when we're just writing it out as a sum here, this is alright. But we would basically have 1 times x to the 7, and you would just move 1 degree at a time down, so we'd have x to the 6th, but we don't have an x to the 6th term, so we can just do 0 times. And then we don't have an x to the 5th term either, so we just do 0 times that, and then we'd have a minus 3x to the 4th. So we're kind of going backwards this way, but my point is that we can actually write this as x to the 7th plus 0 x to the 6th plus 0 x to the 5th minus 3x to the 4th. And now we just go 1 at a time down, so x cubed, there's no x cubed term, so you'd have 0x to the 3rd, and then plus 1 times x squared, and then minus 2 times x, which is x to the 1, and then plus 9 times x to the 0, or you can just leave it as a constant. So for each polynomial like this, you can just fill in zeros wherever there is a missing exponent of whatever it is that we are looking at. And I'm putting the dots for the times just to make it extra clear that the coefficient is the number that is in front, and it's 1 times x to the 7, 0 times x to the 6th. So this part I just wanted to mention. Don't let it confuse you if you have not heard of this before, but a lot of times when people come across polynomials again in pre-calculus and stuff, and they've never seen this before, I've this. So all you should see in whatever summation form that you want, you should have a bunch of coefficients with your variable raised to one power that increases or decreases one way or the other, depending on if you want a0 to be associated with a to the a sub n, or if you want it to be a0 x to the 0. So I've seen this in a few different ways, but the key concept should be there. It should be a sum of a bunch of coefficients times your variable raised to a power, and you should be decreasing that power or increasing it by 1 every single time. So usually when you write polynomials, you'll see it just as x to the 7 like this. You don't need zeros for every term in between, but there are situations when you would want to write out every single thing by decreasing degree, such as for longhand division for polynomials. So we will come back to that another time, but I hope that this gets you started anyway. So basically we want to have, you can start with one term, and there are special names for, like, you know, monomial, binomial, trinomial, and then just polynomial, and you can have numbers. And also, by the way, these are just the exponent rules for your variables, so your coefficients can be whatever you want them to be, so they can be really complicated. You can have, like, I don't know, you can have like 6 pi to the negative 1 over square root of 3 for whatever reason. If you wanted to, you could have fractions, negative exponents, square roots, but as long as you have that part in front of an x to the power of whatever, that power still needs to be a whole number. So these are only the rules for your variable exponents, because this whole thing is just a number. It's still just a constant. It's a messy one, but it's still a constant, so we don't care about that. There are no rules for it. Just try not to break math. But okay, so I think that is all for now. I hope that this was a nice little kind of overview. This part has more to do with when you revisit it again in pre-calculus, I would say, but sometimes you do see this sigma notation when it's first introduced in maybe like algebra or algebra 2. So just keep that in mind. But that's just a fancy way of writing the combination of coefficients, your variable, and raised to a power, and you'll want to either be decreasing by 1 power every time or increasing. And don't forget the 0th power thing makes it the constant term. The first powers are linear terms, so usually you don't see x to the 1, you just see x, and then you start with your quadratic and then cubic and move on from there. Let me know if you have any questions about this at all. Otherwise, we're going to move on to different operations with polynomials, like adding, subtracting, multiplying, dividing, but we will save that for next time. If you are asleep right now, I'm wishing you sweet, sweet mathy dreams. If you're going to continue on with the rest of your day, I hope that it's a good one. Thank you so much for hanging out with me. And let me just put these pens back to wrap it up. And I will see you around for more math very, very soon,